With that, we're going to wrap up our session. Turning back over here to Herman.
We are running late, so we should be quick, but if there's a quick question or two,
building information modeling, that's where everybody's going right now. Right now, I see it stopping primarily with the upper. In your opinion, when is that going to flow down to the people who are actually building the projects?
If I understand your question, you're finding building information models sort of being adopted at the top tier of design, but it's not percolating down to mid-tier firms and other firms. Well, I don't know how to answer the when question on these, because I think from our experience, we are seeing mid-tier firms adopt these technologies. It's just not a widespread, like every company is doing it. But there are several of our clients that are doing it, who are doing this basically retail construction. They're not doing, really fancy structures or anything like that. Because I think the benefits are very clear to people. If you make the initial investment, and I'll let Darren speak to that, I think what stops people is that they sometimes get a little bit challenged by the fact that the early adoption cycle, there has to be an investment made to learn the technology before you reap the benefits of it. And I think people sometimes go through the cycle of when is it the right time for them to make that investment. And increasingly these days it's becoming client-driven. So the GSA, for example, put a requirement out that every future GSA project has to be done or submitted in a building information model format. I think when forcing functions like that show up, the adoption is going to become faster. Otherwise, I think it's happening at a certain pace, and we are seeing it happen in the mid-tier firms as well. Darren, you want to answer the question?
I think there are three areas where we're starting to see the downstream of these models, building information models versus reality. That pretty much deals in the areas of steel, concrete, and brick wall. We are finding tremendous success where we are able to take our steel framing models and work with the steel fabricators and such through Tech Steel and such, and now through Tech's concrete, reinforced concrete, and then working with brick wall vendors such as Rizza, where we're able to share with them our building information models in a variety of formats, because we all make our choices in terms of what software we're using, what data formats, etc. But the world's kind of small when we're talking about these three particular areas, so we know that information up front, what to do. So we're finding that, when we start twisting and tapering and torturing buildings, we understand their skin. The curtain wall is not going to be a series of rectangular pieces of glass that are flat. And so through these models, we're very able to accurately send the information to the manufacturing process. So we're beginning to see that downstream event actually happening. And you can basically look around any major city, particularly New York, and actually here in Chicago as well, and we start to see a variety of building forms that aren't rectangular, and yet we have very complicated panel systems and curtain wall that can indeed match and meet exact specification. And ultimately, we're starting to see behind all of this is the exchange of this digital data that is so key to it.
I have a question for Mr. William Baker. We have been talking about...
We now have 3 microphones, so there should be no problem facilitating.
Mr. William Baker, we have been talking about performance-based design of the tall building. I would like to know what design codes and the regulations have been used for the design of super tall buildings like Burj Dubai or Infinity Tower.
Well, the building codes are the basis, but they're not really written for buildings of this nature. So, taking the minimum standards is a good place to do. We have been using
IBC on a lot of these projects, International Building Code, as the basis. And, you know, and these integrated codes like IBC, where all the different trades are referenced out of one document, helpful from that point. But you really have to go beyond. I mean, there's nothing in the code. The code uses things like a 50-year wind plus load factors. To me, that's meaningless, okay? Because these are dynamic devices, and these are oscillators. And you have to understand the dynamic interplay between wind and things. So you have to like take basically the kernel of what the code is asking, and then come back and reinterpret it in a way that's appropriate for the building type. Yeah, we do start from, you know, in China we use the Chinese building code. In Spain we use the Spanish building code. We use various building codes, but we have to come back and understand what is it they're really trying to achieve, and then what do we think that perhaps are missing that aspects later on to those. So it's, the building codes do not really address it. The performance base does make a lot of sense, where you can say, what is the goal we're trying to achieve? What's the performance we're trying to achieve? And then reach from there, rather than following a set of rules or prescriptions, which may or may not get you anywhere.
Question for the gentleman. One of the major partners in a tall building is, of course, the structural engineer. And in the BIM modeling software we have currently, there's a terrible disconnect between analysis and the building information model. Some very minute details, such as studs on composite beams and the camber of a beam, that is not brought over and made available to the construction site. And there is no back and forth communication for the analysis software to speak to the Revit structures, for example. So there is a huge disconnect. When is Autodesk going to put that on top priority and solve this problem?
Darren wants to ask me the same question. Okay, it's a fair point. We understand the issue that you're flagging. I mean, in all honesty, I think we have recognized that we have a gap in terms of our capabilities on the structure and on the analysis side, and we are making investments to do that. So, you know, Revit structure is probably in its second year of development now, while the building design side is probably in its sixth or seventh year of development. So it's just that the building design side is out ahead today, but our going forward investment is definitely in the structural piece. We also just acquired a company based in France to strengthen our analysis piece around all of the structure. And we are also investing on the building system side so that we can really get the key disciplines coordinated to the model. So, you know, structure and building systems have definitely risen to the top of the list. It's just that we're starting, if you will, almost 3 laps after the building design side had taken off. So I do think that at the same time next year we'll be out much further ahead of where we are today.
Will you cooperate with the other suppliers of analysis software?
Yeah, I think what we are going to do is take an open approach to that. We certainly do want to provide a default solution from us, so that if a customer doesn't have a preferred analysis solution, we provide them one. But if they already have a preferred analysis solution, we'll absolutely link to it and use it in the system.
Well, with that, we should probably wrap it up. And please thank our panelists.
Can I just say as you leave, very loud, can I just say as you leave the hall, dinner is going to be served. We've got to rush a little bit with dinner.